What's up? It's your old pal, Mr. Cook, and we are working through the Unit 6 test review. We've just got through the first page, the front part and the back part. The front part was mostly using properties and also using the exponent conversion to logarithms. And then the back page was, just all solving pretty much all the way through. We talked about all of those different methods for solving, and now we're going to put them to use in these word problems. So the word problems have formulas that go along with them, but luckily for you, the formulas will be provided to you on the test, just like they were on the quiz. So you just need to know how to use those formulas. So let's do a quick recap of the formulas that you're going to see. So one formula that you're going to see is called the compound interest formula. So with compound interest formula, it looks kind of complicated, but it's actually pretty easy. A is equal to P times parentheses 1 plus R over N to the N times T power. We'll talk about what each of those variables mean all at the same time, because the formulas that I'm going to write up here actually use the exact same variables all the way through. So the next formula that you have is your compound continuous formula. So compounded continuously. And it looks like this. A is equal to P times E to the power of RT, R times T. And then the last formula that you have is your half-life formula. Those are the ones that we're going to use a lot when we're not given some value or some expression or some equation in our formula, in our word problem. The half-life formula looks like this. A is equal to P times 1/2 to the power of T over H. All right, so now let's talk about what each of the variables represents. And I'm serious that they mean the same thing for each one of these formulas. The P value that you have is the starting amount, so some amount that you start with. The A amount is the ending amount, so the amount that you have after some amount of time, T. So that's another variable that we use, T. T is the amount of time, and it can be in terms of years or hours. Usually they use years for the compound interest and compound continuously formula, but for half-life, it's open to whatever you really want, hours, minutes, seconds, days, whatever. The other variables that we have are R. So R is going to be your interest rate, and it is very important to note that when you have an interest rate, it needs to be in decimal form. So we'll talk about how to put it into decimal form when we see a couple of these problems worked out. Two more variables that we have this N value on our compound interest formula. That's the number of times that the compoundings happen per year. So number of times per year. And you're going to need to know what that is based off of just a couple of key words that you'll see in your word problems. The last variable that we haven't talked about is this variable over here, H. H is the time that it takes to cut something in half. In other words, it's the half-life time. And these formulas you're going to use for, I guess, just these two, because it looks like number 37 and number 38 have formulas attached to them already, so you're probably just going to need to solve a couple of them, and that's it. Okay, so let's go through number 35, determine which formula that we're going to use, and then go from there. So this says, you decide to purchase a home and need to borrow $200,000. The bank offers a 30-year fixed loan at 4.95% compounded quarterly. Your credit union will face the loan at 7.35% for 20 years compounded continuously. Determine the total amount paid for each option and state which would be a better deal for you based on cost alone. What would the monthly mortgage payment be for the better deal? All right, so this is a multifaceted problem. First off, they give you two different payment options. So the two payment options, let's split those into two different things. One is going to be the bank, and they offer you this $200,000 loan, and when you're paying the loan back, you need to pay interest on it. So you start off with $200,000 that you owe. So if that's the starting amount, then that means that that's the amount that we call P, the starting amount. You're going to be looking for how much money that you end up paying off over the course of the loan, so you're going to be looking for A in each case. And, you use either the compound interest formula or the compound continuously formula for both of these situations. You're going to use the compound continuously formula for the second option, the credit union, because it says a special word that tips you off to knowing that it's this formula, and that's continuously. It says that it compounds continuously, so that's why you use the compound continuously formula. It should be, pretty obvious for that. So that's P times E to the power of RT. And then for the other one, it says that it's compounded quarterly. When it says some amount that it's compounded, and it's not the key word continuously, then you know it's the compound interest formula. So the bank is going to use the formula P times 1 plus R over N to the NT power. All right, so let's write down the variables and then use our calculator to figure out everything. So we already know that P is 200,000. So if I'm plugging it into the formula, I have 200,000. It's 5 zeros. Times parentheses 1 plus R over N times NT. We also know that the bank offers the loan for 30 years. So that's our amount T. So that T value that we have there is 30. It has a fixed loan at 4.95%. So there's our interest rate. Interest rates are always going to be given to you in terms of percentages. You need to convert them to decimals. So here's how you do it. It's really, really easy. You just take your decimal amount, 4.95, and divide it by 100. So if you use your calculator on that, you'll get the exact decimal value. 4.95 divided by 100, 0.0495. And some of you may already know the other trick for it. Just move the decimal place over to the left twice. This, if you've ever made a mistake with that, just do this. It works every time to get the right answer. Okay, so just divide the percentage by 100. That'll be the decimal answer. So our R value is 0.0495. Now we just need to find the N value. So the N value is actually given to you when you're told how it's compounded. It's compounded quarterly. All you need to do is ask yourself one question. How many times per year does quarterly happen? So there are 4 quarters in a dollar, so that means that there's 4 compoundings that happen, quarterly over the course of a year. So that's an N value that's equal to 4. So we just plug in 4 for our N value here and here. And then we just, need to type it into our calculator. So let's see how much money we end up spending back or giving back over the course of this loan for 30 years. So we type it in, 200,000 times parentheses 1 plus, and then we just write that fraction out, 0.0495 divided by 4, and then close the parentheses, raised to the power of, and if you have one of these calculators, make sure to put your parentheses around the exponent as well, so 4 times 30. Enter. So then you should get an answer that is, wow, that's a lot of money that you end up paying back. So it's 874,982.63. And we only go to the hundreds place because it's dollars, and we only go to cents, for that. So that means that overall you're going to pay back, what's the difference on that? $600,000, $670,000. Man, that's a lot of money. Okay, let's check out how much we're going to pay back from the credit union. So we start with our loan of $200,000. That's still the P value. So 200,000. There we go, one extra zero. And then this E isn't a variable, it's just a number. And I'll show you where to find that on your calculator. So it's E to the power of R times T. Now, for the credit union, it says that we have a percentage of 7.35. So we just do 7.35 and we divide that by 100. And we end up with 0.0735. So that's our R value, 0.0735 times T. And then this time it's going to be over the course of 20 years. So we multiply it by 20. And at this point, it's all just calculator work. So what you do is you type it into your calculator, 200,000 times, and then it's E to the power of something. There's an E to the power of something button on all of your calculators. On this calculator, you hit second and then ln. See how it's like the little blue thing back there, E to the x. So that's E to the power of, and then we type that stuff in, 0.0735 times 20, and then close the parentheses, and we get our answer, which is 869,847.0, and then let's round that up to 3. Okay, and let me show you where to find that on your calculator over here. So for the exact same thing, 200,000, and then times E to the power of, so times E to the power of is right over here next to the ln again, so you hit second ln, and now it's E to the power of, and then you type in the rest of it. So 0.0735 times 20, and you should get the exact same number. Yeah, 869,847.0282. Yep, same thing. So see, that's how you type it in on one of those calculators instead. All right, so which one looks better? You're paying back $869,000 here and $874,000. I don't know about you, but I'd probably want to give less money to the bank, as repayment. So I'd probably go with the credit union option. So that answers the first question, which option would be better? And then what would the monthly mortgage payment be for the better deal? So for this better deal, what I would have to do is take this amount, the total amount that I'm paying back, and then over the course of 20 years, that's going to be how many monthly payments? Well, we take 20, we multiply it by 12, and that gives us 240, so 240 monthly payments. So what I'm going to do is take that amount that I started with, 869,847.03, and divide it by the 240 monthly payments that I'm going to make. So let's see how much money we're going to end up spending per month. So 869,847.03 divided by 240. So the mortgage payment that you make per month is about $3,624.36. That's a lot of money per month. All right, so that is the monthly payment, and this is the better option that you would have based off of paying off the loan to the bank. All right, so that's this problem. That's one problem, and that took us 11 minutes because it's multiple steps for this. I'm going to stop this video here, and then I'm just going to continue with the other three problems because it looks like those ones are going to be quite a bit easier to solve. So that's it for this one, and then we'll finish up the word problems here in a second.